Hello, thank you for taking the time to watch this video. This is Ted Fletcher with FMS Integration. I'm going to go over a basic overview of the cable operation on the RLE distance read controllers, and then how to do a calibration based on what we have tied to that system. So starting off, the RLE distance read controllers, whether if you have an old LD2500 model or one of the newer models being offered today, they are considered to be supervised type systems. So the supervision comes in place because the controller is constantly not only looking for a leak, but it's looking for the integrity of that leak detection cable being hooked up to it. So when you look at some of the menus, you'll notice that there's a leg 1 resistance called out, a leg 2 resistance called out. So then if you look at the leader cable, you'll notice there's a white, a black, a green, and a red lead hooking into that controller. So your leg 1 is the white and the black lead. Your leg 2 is the green and the red lead. So the system is constantly checking continuity and for leaks. So it'll send a signal out on the white wire, looks for a return signal on the black, so that verifies leg 1. Then you have a signal being sent out on the red lead and a return coming in on the green lead, so that checks the continuity on leg 2, and then it'll send a signal out on the black lead to see if any sort of microcurrent is returned on the green lead. That would give you the leak indication. So the system is constantly bouncing around between checking leg 1, leg 2, leak, going through its basic operation. So that's where when you look at the controller interfaces, you always want to see that your leg 1, leg 2 resistance is relatively close. If you notice that there's a big variation between the leg 1, leg 2, there might be oxidation or something with one of the connections going along on that path. RLE does a very good job keeping a tight tolerance on that ohms per foot when they manufacture the cable. But if you have a 7-year-old system out there and you've installed new cable versus what's been sitting under the floor for years, you might get a little bit of a variation. So that's where the calibration comes in handy. So going into calibration, you always want to check for a few optional components being added onto that cable system. So the Sense cable itself has an approximate 2.8 ohms per foot. But you could have little variations depending on the age of the system. So that's one thing to keep in mind. How much physical orange cable do you have installed onto the system? The next component that simulates a distance is the weighted cable. That weighted cable assembly simulates 50 feet worth of cable. That connector is used usually for jumping across walls into different perimeters, where you want to have a good designation break from where the leak detection cable stopped before going into that new area to restart its distance marker. And then the third component to keep in mind whenever you're going to be calibrating one of these systems is the optional X connector, which acts as a 3-way branch to be able to split off the leak detection cable to where it simulates 50 feet for each branch. So therefore it simulates a total of 150 feet. So once you have the routing of your cable, as far as any sort of added components that would add resistance to the system, then it's just a simple add up of how much physical cable do you have with those simulated devices. That way you have a ballpark of what your overall cable length would be. And then you can look at the leg 1, leg 2 resistance. As I mentioned before, you always want to make sure that there's not a huge variation between those two leg resistance readings coming through. You should be close. So then you'd want to take the average of those two legs and then calculate it out to be your ohms per foot, which we can adjust from the configuration menu. So here on my screen, we can see I have 300 feet of physical cable, and then I have a leg resistance of 848 in, well, 848, and it's fluctuating up and down by a couple ohms. So once your cable's been installed and it's taken to the new ambient temperature, then you can be able to get a good reading. So on here, see when it keeps jumping up and down, I'll just base it off of 847 ohms being kind of the average on how it keeps kind of moving just a little bit up and down. So if we divide that 847 by 300 feet of physical cable, we come out to be at 2.823 ohms per foot. So in order to make that update, you come over, left click on the configuration tab, come down to leak settings, left click on this, and then here you can see the resistance per foot. So depending on the cable that's hooked on to the system, you can see that we have a range from 2 ohms to 4.250 that we can adjust between depending on how our system is set up. So here I'll just change the last 2 to 2.3, submit the changes by left clicking, come back to home, left click. Now we can see that it's showing about 299. Refresh. Like I said, there's a little bit of oscillation in here, this going up and down, but when you start getting into having thousands of feet hooked onto your controller, this can make a big difference for your pinpoint accuracy. So on older models like the LD5000 series or the LD5100 that didn't have a web interface, you could actually make these adjustments to the ohms per foot through the front local display on that controller. Again, I thank you for taking the time watching this video. If you like what you see, please hit like and subscribe. That way I can keep you up to date with more videos being released from FMS Integration. If you have an application and you have questions based around the RLE Seahawk water leak detection products, please feel free to reach out to us on any questions that you may have. Thank you, and have a good day.